Knots Company welcomes you back to Focus on Automation, where we explore and celebrate advances that empower manufacturing. Welcome back to Focus on Automation. I'm your host, Todd Youngblood, and today we're going to dive into something that frankly sounds a little bit like science fiction, robot vision. But to help us understand it and the reality of all of it, I'm joined by Mr. Sam Biermans. He's channel manager with PickIt. Sam, thanks for joining us.
Hi, Todd. I'm happy to be here. And as you said, some things do sound like science fiction, but that's not always what it is.
I know that, and I can't wait to dive into it. Before we get into the actual technology, Sam, tell us a little bit about yourself and a little bit about PickIt.
PickIt is a Belgium-based company, and we were established under the name as Intermodalics, and we still do a lot of projects on the software side. So purely software, high-end vision, and robotics. And it goes from indoor GPS positioning to, as broad as you can see, self-driving cars, drones, household robotics. During the 2010, 11, 12, we got a lot of requests from different companies about, hey, can you write me software for my camera and my robots? Because we got so many requests, we knew there was a market question about a 3D vision solution that will help people pick up objects from a bin, basically.
Got it.
And that's from where we started, and then we launched a product, what's PickIt 3D. And so I've been working in the company now 2 years, and I've been mainly focusing on the U.S. manufacturing market.
Got it. And what'd you do before PickIt, Sam?
So before PickIt, I worked in the data center construction, and I was a commercial technical responsibility for the whole project, from getting an order in to completion onto 2-3 year projects of data center manufacturing construction. So the building side, the technologies, and inside the data center.
Interesting stuff. That's pretty cool. Right off the top here, as we dive into this thing, I want to spend a little time talking about the differences between 2D and 3D. On the one hand, that's perfectly obvious, but what are some of the implications of that moving into the world of 3D with all this vision technology?
Yes, so what we're basically doing as a company that is moving into the 3D market is also we're building our own market. So a lot of people, especially in the industrial automation world, they know 2D. They know 2D cameras. They know their capabilities, they know their strengths, but they also know their weaknesses. Because people know 2D, there's also a lot of workarounds to get a 3D situation into a 2D scene where a 2D camera can handle it. For example, vibration tables, mechanical singulation projects. So 2D cameras are great for a lot of solutions that are out there, but a lot of people are also working with 2D where they could benefit more from 3D. What is the biggest difference? That a 2D system is perfect for doing quality control, barcode reading, color scanning, surface controls, those kind of things. Where a 2D system struggles is part singulation. So once a part is singulated, a 2D system is brilliant. That's also not what we're aiming for with our company, because we know that the 2D systems who are out there, Cognex, Keyence, all the other guys, they're perfect in doing a quality scan on a singulated object. Where we're moving in is before you get the object singulated, that's where the 3D comes in handy. Because then the products lie in different orientations, they lie on top of each other, they lie touching, they lie in a dirty environment, all of those kind of things. And that's where a 2D system has more, I wouldn't say limitations, but it has not the capabilities to handle this.
In terms of the markets that you're aiming at, Sam, it sounds like it can be very broad in terms of any bin picking sort of application. Is that true, or are you looking at a more narrow set of applications?
Yeah, it's good to ask that question, because we see a lot in the world that people on LinkedIn and wherever the marketing strategists say, hey, bin picking is solved. So we as a company, we're not, you probably have heard or seen those kind of sentences.
Yeah, actually, I thought bin picking was solved about 20 years ago.
Yeah. So that's the funny thing, because that's not what we're claiming. What we're trying to do is we're trying to help manufacturing companies who struggle with finding labor forces to do repetitive tasks. There was a big wave in automation when robots started. People started learning, hey, we can do repetitive tasks, we can do certain things. Now, a lot has been automated last years, and then with collaborative robots, there was a new wave coming in. What suddenly was possible that you worked as alongside a robot without having fences, cages, or without having people that are highly skilled trained for it, because it's now accessible to more people. And that's what we're trying to do. We're not trying to solve every bin picking application. We're trying to help people solve applications by doing it themselves. You can go to an integrator and pay 300 grand to get him fixed a 3D bin picking solution for one product in your factory. That has been solved, that has been done. What we have is an off-the-shelf product that you can integrate with your robot, and it helps you to solve certain applications. How do we qualify these applications? We always test the products. So we have a comfort zone, what we call the typical applications. What are these? These are most of the time picking steel billets and then putting them in a heat furnace, picking drive shaft couplings, picking objects that are fist-sized, that are metal or plastic, and they're in a bin, and now you need to singulate them because you're going to grind them, you're going to heat treat them, you're going to whatever you want to do with them. And that's something we know we do, and we do it fairly straightforward.
Okay, it sounds like the payload that you can handle is all over the place, from steel to small plastic parts. I want to make sure I heard that correctly.
Yeah, but so the payload is not something we do. So you can couple us to any robot. So
I got
ABB,
it.
Fanuc, Kuka.
Okay.
And so basically what we're basically a sensor where your robot can ask a question to. What's the question? Hey, PickIt, I'm looking for this object. Can you find it for me? And PickIt will tell the robot, yes, I find it for you. And it's lying here, XYZ orientation, but also XYZ rotation. So that means that a robot can go into a bin and grasp an object on a certain spot of hole. For example, if you have a dry shaft that's just been milled, you don't want to grab it on a milled surface. You probably want to grab it on a thicker edge or something where you don't damage the milled surface.
Right, right.
The thing about 3D is that we don't really understand as a human how it works because we use it every day, and our eyes are the best 3D camera in the world. Our eyes together with our brain can handle a lot. Dark light, very bright light, surfaces that are complete flat. Because we have a brain, and that's the artificial intelligence behind it, we know what we're seeing. A 2D camera only sees in one plane, while a 3D camera sees into 3 dimensions. So not only a plane, but they can also see the Z or the depth information.
I'm the guy on the factory floor, and I'm saying I'm looking to automate more and more of the whole manufacturing process. Walk me through what's my decision process? How to first do I identify what I've got that lends itself to a 3D application? And then how do I begin to step through that, doing the design part of it, figuring out the financial part of it? Just walk me through how I would do that.
So what we always suggest people is, if it's possible, start easy. So that's also how the first robots came into factories, how the first collaborative robots, that's also how you should work with vision. So what you should try to do is you should try to run into your manufacturing floor from where raw goods or materials come in. So that can be either purchased plastic parts, purchased forged parts. They come in, and at some point they need to be singulated, like everything, because you're going to handle those parts or you're going to assemble those parts into something bigger.
Got it.
A lot of the automation has been done between once the part is singulated until a finished product. And there's basically 2 zones where you could use 3D vision. One is the part is manufactured into something else, and now it comes out of a conveyor. But the robot doesn't know always how the part is lying.
Right.
Is it orientated around? Is it rotated? But most of those things has been done mechanically, because in the past there wasn't 3D systems. But on the other spectrum, in the beginning of the manufacturing, a lot of people have trays full of objects where people are singulating, just taking a product the whole day and putting it somewhere. Or they're using big vibration tables who make a ton of noise, take up big floor space to get those parts into a 1-by-1 position.
Mm-hmm.
If you have a product that you think, hey, I have an idea how to grasp it, because we will come later to the grasping of objects. Finding an object is most of the time not that challenging for our vision systems. The way you want to take an object is most of the time more challenging. And there's a lot of integrators in the US who have knowledge about building grippers, but these guys are very good at keeping their knowledge. So we get, for example, a lot of requests from companies, hey, I have a very special part, let's say an engine head, because everybody can imagine how an engine head looks, and I wanted to take it into the 2 holes where I go in with my spark plugs, for example.
Okay.
it's all fine. But if you don't see, if we can find your object and the object is tilted, we can still tell you where those holes are. But how are you going to go in with a robot? Because a robot is not a hand that has unlimited movement of joints. You only have 6 or 7 axes.
Correct.
So from every side you look at it, you need a different pick frame and a pick point. So it could be that if you look from one side, you can go perfectly in the holes and open up and grab it. From the other side, the holes are maybe not visible or not reachable. So you maybe need a 2-finger gripper that can clamp and close, pick it up, drop it somewhere else, and then you can go back into the holes. And then from another side, you may need a different kind of gripper. So the whole design of a gripper compared to the complexity of a product is important when you start with automation with 3D vision. You don't have to worry that much about finding what's in there, because if it's not translucent and it's not mirror-like stainless steel, most of the objects can be found by a 3D system.
Typically would I need an integrator to help me with that gripper, or is that something you talked before a little earlier about being able to do it yourself in terms of the programming? Is that apply also to the gripper, or do I typically need an integrator to help out with that?
Yeah, so that's why I say start easy. If you have cylindrical kind of parts or plastic parts or parts that you want to grab out of a bin, and you know that you can approach them from above, that means either use a vacuum gripper or a magnetic gripper to pick them up. That will give you a ton of freedom. Why? Every flat surface that you have, you can pick something up straight from above. You don't need fingers to go in holes. You don't need fingers to open. You don't need things to close. And it gives you more freedom to play around with, because most of the time, every visible surface from every side that is flat will allow you to pick it up. And that's something you can do yourself. The moment you go into high-end custom grippers, you probably need an integrator unless you have some engineering in-house. But the more simplified applications where you have a magnetic gripper or a vacuum gripper, it's easy to buy, it's easy to build, especially now in the collaborative world. You have a few guys who have even vacuum generators that you can mount on the robot head. Magnetic grippers supplied by the typical gripper companies. So there's a lot to do there, and it's moving very quickly. For example, we have Vanomatic, KYB, 21 Plastics. There are 3 companies who had time and resources and technical knowledge in-house, and they just bought a PickIt box. They bought a UR, Universal Robots. They designed a very basic gripper, and then they figured out, hey, with this technology that we have, we can do this. They found in their plan one project that they could work on, and they learned by doing it what other applications they can do, and now they're all running with multiple vision systems, 3D vision systems.
I got it. So that, the old adage of walk before you run really makes a lot of sense, very applicable right here. Yeah. Sam, let's switch a little bit and talk about the economics of it, and give me an idea of what kind of break-even points you can get or return on investment. What's the money side of it?
So if we talk about the money size and return on investments, so a lot depends on what kind of robot brand you're using, but you have to count for vision systems that they can vary between 20K up to 40, 50, 60K. Now, PickIt, we have 3 different models. So we're more between the 20K and the 37, 38K, depending on what kind of model you want. So we're in that price range. That also means if you add a robot, you add some grippers and you add fixtures and everything, you're around 100K to have a small cell up and running.
Okay.
If you look at labor costs in the US and you count the shift hours and everything, then for a lot of projects where you have a product that you can run in 3 or 4 shifts, you should be able to reach 5 to 6 months on return on investment.
That's pretty quick.
Yeah. Not by eliminating those people, but by helping those people quit repetitive tasks, because everyone that works in a plant as a labor force should be able to add more value than doing a repetitive monotone task.
Yeah, no, there's no doubt about that.
And that's our true belief in our company. So we're not trying to get people out of the jobs by putting robots there. We're trying to move people from doing repetitive monotone jobs who are basically not good for motivation into a state where they add the human knowledge and the human interference into a manufacturing process.
Talk a little bit about the quality aspect of it. I imagine there's got to be an increase in the quality of the manufacturing product, just because I got the orientation of everything is correct. Is that another area where I can get some ROI?
Yeah. So why I'm saying 5 to 6 months, that's the ROI that we calculate if you take into account everything. So you're not only taking into account your labor force, you're also eliminating human errors. It's not bad because you learn from human errors. And I think human errors are essential for manufacturing and for moving forward. But in some processes that are fine-tuned, we should eliminate them. For example, we had a customer who is basically just order picking. So he needs 10 bolts in a bag, 20 washers in a bag, and 40 support struts in a bag. Why is it? Because that bag goes with a lot of metal frames, and he sells it as warehouse racks. So a project, for example, of $200,000 with warehouse racks gets bought by him. He assembles the metal part, but then he also needs to bag the small components that are there. But imagine you buying a 200,000 or 300,000 project, and one of the important bolts is missing. The whole customer experience is bad because the whole product is not good. And so he said, my return on investment is 0 on saving costs, but on my customer experience, it moves gigantically because the robot counts and it doesn't make mistakes.
You only need to prevent one of those with a major customer. Sam, talk a little bit about the support structure. How are you going to market, particularly in the U.S., to make sure that the knowledge in terms of identifying applications, getting the right design done, implementing, et cetera? How are you supporting your customers?
As I mentioned, we're a Belgium-based company. Our headquarters in Belgium. We have certified channel partners in the US. We have about 15 of them. They all have a demo unit. So what means they can all test products. So what we're trying to do is especially not sell our technology where it is not perfect for an application. So we're trying to test every product that we get in as a question. After some evaluation on sales cycle and on sales evaluation, like, hey, yes, we will make a proof of concept for you. We will show you what we can do with our technology. That allows the customer to get more confidence in a new technology as 3D. By doing that, on the other hand, we're training our partners in how to set it up, how to run. So our partner network does the first line support on sold systems in the US. On the other hand, because we are a global company, we will establish normally by the end of 2020 an office in the US, so local presence. Why do we believe that we need a local presence in the US? Due to the time shift, but especially because it's one of our focus markets. We know that there are about 5 million job openings will be created in manufacturing in the next 10 to 15 years. And probably 40% of those will not be possible to fill in.
Right. That's going to be a heck of a problem.
Yeah. So that's a heck of a problem. What's really important for us on the support side is that because we still design software and we design our own software in-house, we build in a lot of capabilities. One of the things we have is that you can connect your system online. I hear now already on the other side of people listening here, everybody who works in IT is now moving back into his seat and saying, nobody goes online. Yeah. We're ready for IoT and we're ready for big data and we can transfer the data. On the other hand, what do we have? We have a tool that's called a snapshot. To try to simplify what a snapshot is, it's basically taking a screenshot on your computer, but it's a snapshot and it's a document that saves the entire 3D scene. So what the camera is seeing in 2D, what the camera is seeing in 3D, plus all the settings, and it crops it into a very small file that we can open on any PickIt system. You can download it from your system. So even if the PickIt system in production is not online, you can download that file, put it on a flash drive, email it to us from your normal computer, and our support engineers anywhere on the world can work on it on a virtual system. We can tweak the settings. We can tell you, hey, but you put a value on 100. That should not be 100. That should be 10. And send back with the right settings. So we can do on-site support without being on-site.
That's pretty exciting stuff. Sam, before I let you go, I want to ask you to peer into your crystal ball a little bit. What do you see coming next over the next 3 to 5 years? How are we going to build on this technology, and what sorts of things do you see happening?
So I think what's the most interesting for us is that more people are moving into the 3D market, 3D vision market, because we need everybody. We need everybody to work together to get people who are biased on it's not working and it's not ready to convince them that it is ready and that there's a era coming now where you can do a lot more with robots because we have 3D capabilities out there. So that's the main thing. And the ball is rolling slowly, but at some point it will get a snowball effect. if you know what I mean.
I know exactly what you mean. Yep.
And that's why we are at the forefront. We're the forefront fighters. That's why we're also investing so much money in R&D, because we want to stay on the tip of that mountain and move as the high-tech best vision solution that's most usable and scalable for bigger companies. We're talking with a lot of bigger manufacturing companies in Europe because it's our home base, and they all like what they see. And they all say, we have to move with you guys into this market, and we have to see maybe to adapt some things to really scale it up in our company. So what I see in 5 to 10 years is that where we are now with 2D, what everybody knows, what everybody can use, what everybody understands, that will be 5 to 6 years 3D.
Got it. So it's not the least bit science fiction. This 3D robot vision is for real, and it's today.
So not only is 3D being used for bin picking, 3D is everywhere right now. Everything has to do with automation. So there's self-driving cars. They use LiDARs. They use 3D information. There's drones who do inspections on high-altitude buildings, on electricity distribution networks. There's indoor GPS positioning that doesn't work. So they use 3D information to know where the robots are, household robots. There's logistics scanning in warehouses. There's even Walmart is doing scanning on their inventories. So the 3D allows robots to do a lot more. And I cannot stress it enough. It's not that robots will steal human jobs. It's to get people out of monotone, dangerous, non-ergonomic workspaces. Because I believe, and I'm a strong believer in this company with everyone here, that people should be able to add more value. And there are more valuable jobs. And if people are interested, you should look online to some of our testimonials where we talk with people who actually before worked on a production line where they had to, for example, singulate small parts into a fixture. And now by doing that, they have 4 robots that they are responsible for. And they have more responsibility. And now they are more of a manager of 4 robots who do the same task of them. They still have to check them if they're running, if they have enough material to run, but they don't have to do the monotone, repetitive task every day anymore.
Right. It's an upgrade of the job.
It's an upgrade of the job, indeed. That's the right term.
Just to get us wrapped up here, Sam, how can folks learn more about PickIt, the applications, the technology? Give us an idea of how to get at this.
Okay, yeah. So New York, New Jersey region, we have one of our partners who is Knott's company. And so the Knott's company is one of our certified partners. So they have a demo unit. They have partnership with PickIt. They do New Jersey and Metro New York area. So they can test all of our products. They are already 67 years, I think, or 76 years in industrial automation. And they have 2 upcoming shows. So one is on October the 4th. That's NGMEP's 2019 Manufacturing Day in Somerset, New Jersey, and then October 23 and 24, Design 2 in Park in Oaks in Pennsylvania.
And how can folks get a hold of you, Sam?
Okay, so how to get a hold of us? So we have a website, pickit3d.com, and on that website there are all our contact details. If you want to find me on LinkedIn, it's Sam Biermans, so a Belgian beer guy basically, but then in Flemish. But if you email info or sales at pickit3d.com, you end up with any of our team, and we'll get you sorted out.
Outstanding. Sam Biermans, channel manager with PickIt. Thanks for taking the time to share your insights and expertise. It's fascinating stuff.
Okay, thank you, Todd, for this interview. It's always nice to talk about where we are and where we're going.
Great. Thank you, Sam. That wraps today's episode. On behalf of my guest, Sam Biermans, and our sponsor, the Knott's Company, I'm Todd Youngblood. Talk to you again soon.